Hi, welcome back. In this lecture, I want to talk about the IBM Qiskit, that is one of the most established, most used programming frameworks for programming quantum computers. In this lecture, I just have time to give you a broad overview of the framework and what are its components, what are the different parts of this framework, but I'm not going to go into details. During this course, we are going to use IBM Qiskit, for instance, to formulate a quantum circuit using Qiskit quantum gates formulation. We're going to use Qiskit to run on a quantum computer and to use the quantum simulator. But let's start with the lecture. So Qiskit was developed by IBM Quantum and released in 2017. So the first 0.1 release was on March 7, 2018. It's an open source project, so we can actually contribute to the development of it. Released with the Apache 2.0 license. It's available on GitHub, so you can download it, clone it, and install it on your machine. And there is quite a large documentation about Qiskit. So I think one of the most important part about Qiskit is really that it provides lot of documentation, lot of tutorials on how to use it. And therefore, it's very easy framework to use because there is always some document we can go and study. So during the last years, Qiskit has continuously evolved to include advanced features, tools, and contribution from all the quantum community. This is the full overview of the Qiskit software stack. As you can see, the complete software stack is quite modular, and he has parts that are low level. For instance, we have a number of hardware that provide the interface to Qiskit, but also Qiskit itself provides simulators, so we can use our own classical computer to simulate the quantum computers that in many cases are not so easy to access, right? So we need to buy tokens or we need to be in a queue. So we often use a quantum simulator for our experiments. There's a middle layer that provides the core capability of Qiskit, how compile, how to express our quantum circuit, and this is called the Qiskit Terra. And then there is a number of high-level libraries, for instance, for doing quantum simulation, quantum finance, and machine learning, and then some more low-level application for doing experiments with the quantum computers. But let's go through all the different components of the Qiskit software stack. As I told you, there is the Qiskit Terra that provides all the core capabilities of the frameworks. So in particular, Qiskit Terra allows the creation and manipulation of a quantum circuit. So when we're going to express our quantum circuits using quantum gates, we're going to use Qiskit Terra. Quantum gates, measurement, and classical operation are combined to build the quantum algorithms and are part of Qiskit Terra. Qiskit Terra and its core capability also includes tools for circuit optimization. It turns out that we can improve and optimize the expression of our circuit. We can use a transpilation, that is the capability of going from one circuit to an optimized one, and also how to visualize the quantum circuit. As I told you, in this course we are going to use most of the time quantum computer simulator that allow us to be quite fast in prototyping quantum circuit and quantum algorithms. And this goes under the name of Qiskit Air. Qiskit Air offers a range of different quantum simulator technologies for testing and debugging. The most established quantum computer simulator is called the state vector quantum simulator that provide us all the information about our quantum bit. And it provides a means to simulate the idealized state evolution. What it means, idealized? It means without noise, right? Without having errors and noise impacting our simulation. In addition to this idealized simulation, Qiskit R also provide so-called noise models to simulate the effects of real quantum device imperfections and errors. The part related to quantum error corrections and machine characterization, for instance, what is T1, what is T2 on the machine, that goes under the name of Qiskit ignis, that is fire in Latin. So Qiskit ignis component focuses on quantum error corrections and characterization of the quantum machine system. It offers tools for measuring and mitigating errors, calibrating qubits, and benchmarking quantum devices. Ignis plays a critical role in enhancing the performance of quantum algorithms, especially equipping with quantum error correction algorithms. Finally, Qiskit provides a very high-level interface that allows to be productive when designing quantum algorithms and quantum application. So Qiskit Aqua, that is water in Latin, focuses on high-level application. Aqua focuses on developing quantum algorithms and application for very different domains, from chemistry, for instance, Qiskit nature, finance, optimization, and machine learning. Aqua also includes pre-built algorithms for this different domain and plays a crucial role in advancing more high-level quantum computing practical application like optimization, cryptography, and machine learning. An important part about IBM Qiskit framework is that allow us to access real quantum computers. So it provides an interface to interact with the quantum computers. And I put here, for instance, a snapshot of the website that allows us to interact with the Qiskit. So Qiskit provides a bridge between theory and practice, that is the real quantum computers, by allowing users to run experiments on the real quantum devices. So for instance, the IBM quantum platforms offers cloud-based access to various IBM quantum processors, and the user can submit and monitor jobs, analyze the results, and gain some insights on the behavior of the quantum computer system. So the main programming approach for Qiskit is using Python. So it turns out that the backend for Qiskit is written in C++ and a number of libraries, but we can use Python at a more higher level programming language to program Qiskit. So Qiskit is leveraging Python. You can install the Qiskit on your system simply by pip install Qiskit. And in order to use it in our Python code, we just import the Qiskit modules such as quantum circuit, R for the simulator, and execute to actually run our quantum circuit. As I told you, Qiskit provides a set of functions and modules to building quantum circuits. So for instance, we can use quantum circuit class to create circuits by adding quantum gates and measurement. We can use Qiskit to use quantum computer simulator with R. Since Qiskit R provides a number of simulation backends from state vector to tensor based quantum computer simulator. And as I told you also, it provides some means to run on real quantum computing hardware. We're going to talk about later on about Qiskit in more detail. This is the last slide of this lecture, and talk to you soon.